Good morning everyone. Good morning. So today we are going to discuss about aromaticity, anti-aromatic, non-aromatic compounds. So how can you find out aromatic, non-aromatic compound? We will discuss now. Understand? Here listen. So before this, to find out aromatic or non-aromatic or anti-aromatic, we have some rules which will identify the aromatic or non-aromatic. So what are the main rules or what are the main structures or features of indicating that compound? So mainly this is aromaticity. Aromatic means, so first of all, this molecule must and should be cyclic in nature. This should be cyclic, not a chain. It should be cyclic. Here also planar. Planar means already I told you, if only sp carbons are there, then in cyclic manner, it is also in cyclic manner. In cyclic manner, sp hybridations are there, so it should must and be planar. If sp2 is there, only sp2 carbons are there, it has to be planar molecule. If mixing of sp and sp2 carbons are there, it is also planar, but only one exception is there. If carbon undergoes sp3 hybridation, it will not planar, so it is non-planar. So you have to remember that one. Here complete conjugation should be there. Complete conjugation. This is next. For aromaticity, 4n plus 2 5 electrons should be remained. 4n plus 2 5 electrons should be obeyed. For anti-aromatic, it is 4n 5 electrons obeyed, but here not obeyed. Cyclic totally same. Second one also same. Third one also same, but fourth is different. Fourth is different. If this is not complete, it is non-aromatic. It is non-planar, it is non-aromatic. But these three conjugations, these three structures were exact made for anti and aromatic. But no, you can't explain but cyclic nature. You can't explain on the basis of conjugation or not. Okay? Okay, I will give one example. I will some example. One more is there. Stability order is there. Stability order. What is the stability order means here? Aromatic molecule should be come first. Aromatic molecule should be come first. Then non-aromatic. Then anti-aromatic. You have to remember. Aromatic should be come first. Why? Because stability is more. Then non-aromatic, then anti-aromatic. Okay. Coming to the aromaticity, I told you 4n plus 2 5 electrons. Here if you take n is equal to 0, what happens? 2 value there. If n is equal to 1, what will happen? 6. So n is equal to what happen? 10. 10 will be there. Just adding 4. So 14, next to 18, 22. They like this number present in this 5 electron. These are 5 electron. Not n value is 5 electron. Don't take n as a 5 electron. You have to consider these values as a 5 electrons. If 6 electrons are there, 4n plus 2, that is aromaticity. Coming to this one, 4n 5 electrons rule is for anti-aromatic. Anti-aromatic, you take 0, n value is 0. What happens? Total is 0. Then n is equal to 1. What happens? 4. Next n is equal to 2. What happens? 8. Now adding 4. Each and every 12. Next to 16. These values are not equal to these values. You are getting my point. So you have to remember that like this. Okay, I will give some example. You can understand easily. Okay. Okay. Listen here. This molecule is a benzene. You know that very well about this. Benzene. So today we have to discuss about how many 5 electrons will be there. 5 electrons. 5 electrons means here one bond is equal to how many pi bonds are there? Carefully observe here. How many pi bonds are there? 3 pi bonds are there. 3 pi bonds means 3 pi bonds. Each bond, how many electrons we have? Each bond contains 2 electrons. So 3 bonds, totally 5 bonds. So how many total electrons there is? 6 pi electrons. 6 pi electrons are there. 6 pi electrons will be formed in which form? 4n plus 2 or 4n? So this is 6. So it is obeyed in 4n plus 2 5 electrons. By taking n is equal to 1, we will got 6. 6 is a number present Now here listen, this is 6 pi electrons. 6 pi electrons from 4n plus 2 rule. So it is aromatic. So aromatic compound is there. So before aromatic compound, don't go by seeing electrons. First you have to go through complete 4 features are there. First one should be cyclic. Second one should be planar. Third one should be complete conjugation. Fourth one is the 4n plus 2 pi electron. If you take by seeing 6 pi electrons like this, so they will give like this also. They will give like this. It has 3 pi bonds, so 6 pi electrons are there. 6 pi electrons means, is it aromatic? No, it's a chain. It is not a cyclic. So don't go through by seeing pi electrons. First of all, you have to follow rules. Okay. First rule is should be cyclic in nature. So coming to this first rule, I am giving first rule. First rule, tell me cyclic. Cyclic is okay. Cyclic, done. It is in cyclic nature. Second one is it planar or non-planar? Planar means sp2 hybrid, sp2 carbons are there totally. sp2 carbons are there. sp2 carbons are there. So it means it must be in planar. So it must be in planar. Okay, it is also complete. Third point, complete conjugation. Complete conjugation. Conjugation obeying or not? So this will bond shifted to here. This bond will be shifted to here. This bond will be shifted to here. So complete conjugation is also present. So it is must and should be there. Next, now we know you have to calculate 6 pi electrons are there. 6 electrons, 5 electrons is in the aromatic 4n plus 2 rule. So that's why it is a aromatic compound. Coming to this point, what happens here? Sir, it is a positive. Then first of all, what is the first rule? First rule, it is cyclic or non-cyclic? Cyclic. No, it is a carbon. It's a cyclic. So we have to consider it as a cycle. Okay, first one is cycle, done. Over. Second one is, what is that? Planar. Planar or not? Planar. So this is planar. This is sp2. This is sp2. This is sp2. Now tell me, this is for sp2. I already told you, if minus is there, it is in conjugation process. Resonance is there. That's why it is sp2 hybridized carbon. sp2 carbon. So that's why it is also planar. Now tell me, is it complete conjugation or not? Yeah, complete conjugation. Why? Because here is there alternate positive charge like this. So if it will goes through, it will positive here occurs. So complete conjugation is also present. Complete conjugation. How many pi electrons are there? One bond is there, one pi bond is there. 2 pi electron. 2 pi electrons present in where? So 4n plus 2. 4n plus 2 is the feature of aromatic. So finally it is what? Aromatic compound. So like this you have to remember what it may be, aromatic or non-aromatic. Come to this point, what happens here? Listen. What happened? You got answer? So first of all, is it cycle or not? Is it cyclic? Okay, next what happened here? So first this process is must and should be cyclic. Is it first preference is cyclic? Yeah, it is a cyclic structure. Next one is planar. Is it in planar or not? It is in planar or not? This is minus charge. I told you minus charge is there. If it minus charge like this, so what happens? Actually it is sp3 hybridization. I told you that. But when conjugation is there, if conjugation is there, we have to consider it as sp2 carbon. So this is sp2 carbon. This is sp2, total sp2. So it is must be planar. Okay, done. Is it complete conjugation? Yeah, it is complete conjugation. Minus will transfer to here. Bond will transfer to here. Complete conjugation is there. Conjugation complete is there. So coming to the next point, fourth one, is it 4n plus 2? How many pi electrons are there? 2, 1 minus or 1 bond. 1 minus is equal to 2 electrons. 2 electrons. We have to consider 1 minus as a pi bond. This is 3 bonds are there. It means 6 pi electrons. 6 pi electrons for aromatic rule. So this is a aromatic compound. Aromatic compound. Next, come to the next one. What is going there here? Means listen. So this is a sp2 carbon. This is sp2 carbon. This is sp2 carbon. Here also we will take it as a sp2 carbon. So first of all, cyclic or non-cyclic? Cyclic. Very good. Next one is planar or non-planar? All are sp2 carbon. That's why it's a planar molecule. Third one, complete conjugation is there. So how can you find out complete conjugation? So still here it's okay, but here what happens here there? Suppose this bond is shifted to here, it will get positive charge. this bond will be shifted to here, this bond will be shifted to here. So if a bond shifted to here, positive charge will be lost. What happens here? What happens here? This bond shifted means here we will get positive charge. That's why totally conjugation will be occurred. So complete conjugation will be present. Complete conjugation will be present. So how many electrons are there? 6 electrons, 6 pi electrons. Don't consider positive as a pi bond. Okay, whatever it may be in the ring, pi bonds and minus. We have to consider these charges only. So totally 6 pi electrons. 6 pi electrons for aromatic compound. Aromatic compound. Next, come to this one. This is structure is very easy, but it looks like very difficult. Okay, first of all, this is a structure and this is also. You will see here no bond is there. No bond is there. Carefully listen. Here to here, this bond is there. Double bond is there. So complete conjugation will be there also. So suppose I want to separate it. It will get negative. It will get positive. This ring, how many pi electrons are there? So first of all, is it cyclic structure? Yeah, first this ring cyclic structure. For this ring also cyclic structure is there. So what is that? First rule is over. Second rule is planar molecule. All are sp2 carbons. So that is also sp2. Here positive charge means what? sp2. Third one what? Complete conjugation is there not? Okay. Here complete conjugation. Here 6 pi electrons. Here also 6 pi electrons. 6 pi electrons for aromatic compound. Here also aromatic compound. Totally we got aromatic compound. Okay. Understand? Next. Another one, last compound is there. Okay. Listen. This is a complete conjugation. Cyclic structure is there. Planar molecular not. So it will divide like this. This bond will shifted to here. This will get positive. This will get negative. So 6 pi electrons are there. Okay. Complete conjugation, planar molecule, sp2 hybridization. So total is this. This is also aromatic compound. You have to remember. Next one. Next listen. What happens here? So some examples are there. These are, I told you 6 pi electrons aromatic compound is over. Next here listen. So oxygen, sulfur, nitrogen is there. This compound is like this. So all these are compounds are same. Up to here same compounds. It is maybe one carbon is more. That's all. But all features are same. So listen here. Oxygen is there. Oxygen has how much? So here is there any conjugation? You looks like no conjugation will be there. No positive charge, no negative charge. How can you find out? So but complete conjugation will be present. Why? Because of lone pairs. Here oxygen will get lone pairs. Here lone pairs. Here one lone pair is there. So what's going here means, so it will transfer to here complete conjugation. Actually, first of all, first one, is it cyclic or not? Is 3 or 4 of them are cyclic or not? Yeah, cyclic. No, totally cyclic they are. So second option is they are in planar or not. So yeah, planar. It is also transferred to here. Here also transfer to here. It will also transfer. So complete double bond will become. So it will access. What happens? Access sp2 carbon. It will also sp2 carbon. Why? Because same oxygen group it is. Nitrogen also same like this. sp2 carbons. Here also sp2 carbons. Next third one, complete conjugation also present. Complete conjugation. Fourth one, 4n plus 2 5 electrons. Here how many electrons are there? So 5 electron is there. We have to include or not? So already double bond is participating in conjugation. We don't take lone pair as a conjugate. Why? Because for this atom, for nitrogen side, already double bond is involved in conjugation. That's why lone pairs will not involve. If any bond is absent, double bond is absent, then only we have to include lone pair. Understand? So how many lone pair of electrons are there? How many pi electrons are there? 6. Here 6 pi electrons. Here 6 pi electrons. Here 6 pi electrons. Here also 6 pi electrons. Totally 6 pi electrons. 6 pi electrons are included under aromatic compound. So these are aromatic compound. Okay, I will accept this. So coming to this one, what happened? Okay, what is this neutral atom? So 2 pi bonds will be there. First of all, complete conjugation is there. Second one is planar. Why? Because sp2 carbon, sp2 carbon. Complete conjugation is there. Yeah, bond versus alternate bond. So complete conjugation is there. Is it 4n plus 2 or 4n? How many pi electrons are there? 4 pi electrons are there. 4 pi electrons comes under 4 plus 4 and 4 pi electrons for if n value is 1. it is comes under anti-aromatic. It comes under anti-aromatic. Comes to this point, what happens? Is there any positive or negative charge? No positive, no negative. So here double bond is 2 5 electrons are there. Sorry, 4 5 electrons are there. Is it cyclic? Yeah, cyclic. Second one, is it planar? Come to the planar. Is it planar? Listen, is it sp2 carbon? Is it sp2 carbon? But here 2 hydrogens are there. No positive, no negative charge. If positive, negative charge is there, we can consider it as a planar. But here it will undergo sp3 hybridization. If any place, if anywhere we find any sp3 carbon, should complete any sp3 carbon, so it is in non-planar. So that's why it is a non-aromatic compound. Non-aromatic, but not anti-aromatic. But for anti-aromatic, it must and should be sp2 carbon. Next, coming to this point, what is going there? So it will be sp2 carbon itself says, so it is a aromatic. Sorry, 4 electrons are there. So that's why anti-aromatic. Here 8 electrons are there. 8 electrons are there. First cyclic. Next, is it planar? Yeah, sp2 carbons are there, so it is cyclic. So and planar molecule. Complete conjugation is there. 4n plus 2 5 electrons for what? 8. For 8 what? 4 plus 2, 4 2s are anti-aromatic it is. If you 4n, 8 electrons for what? 4n is equal to, n is equal to how much? 2. You will take like this. So if it is like, if you use like this, it will wrong. Why? Because this molecule is in sp2 hybridizer carbon. Next one here, what's going there? Yeah, it is anti-aromatic, you know that. Coming to this point, I already told you, this is 8 electrons. So by considering rules, it will comes under anti-aromatic. It will comes under anti-aromatic. So, but if you keep an answer as an anti-aromatic, it is not correct. Answer is non-aromatic. Non-aromatic? How is it possible? Already I told you, in this form octahedrine. So what is going there? In this form, this compound will not exist in stable form. So stability will be formed in this shape, boat shape, like this. This is the shape for this molecule. This is the correct. Is it in planar molecule? In linear, in planar molecule, it is not in planar. This carbon is not in plane. So that's why it's under non-aromatic. You have to remember. Coming to this point, what's going there means here what's going there? This will be shifted. This will be shifted. So this electron will be shifted to here. Hydrogen will be away. So what happens here? Negative charge will be there. Complete conjugation will be there. Totally 6 5 electrons will be there. Aromatic compound is there. Aromatic compound. Okay. Okay friends, next concept is double bond equivalence. Double bond equivalence. How can you find out double bond equivalence? So today we are going to discuss about this. So what is the DBE rule we have to find out? DBE rule. What is DBE rule means? C plus 1 H plus X. So this is halogen. This is halogen. This is nitrogen. Number of nitrogen. This is number of hydrogen. This is number of carbons. We have to find by this formula. So one example is there, C6H6. So what DBE rule? How can you find out DBE rule? Carbon number, how many carbons are there? 6. So plus 1, okay, minus hydrogens, how many are there? 6. So is there any chlorine or halogen atom is there? No. Is there nitrogen atom? No. By 2. So finally which value we got? 7 minus 3, 4 is there. So when they give formula, molecular formula, by using molecular formula, we can calculate by this formula. So if they given structure, how can you find out? So by counting this number is too much straight. So that's why another way is how many pi bonds are there? So 3 pi bonds are there. 3 pi bonds are there. 3 pi bond, not take electrons number. 3 pi bonds are there. How many rings are there? 1 ring is there. By adding 1, we will get 4 number. Double equivalence value is 4. So coming to this point, so C2H2Cl2, what is the value? Please do and tell me in comment box. Okay, first of all, C2H2Cl2. What's going there? C2. How many carbons? Double bond equivalence formula. Carbon number, how much? Carbon numbers. C plus 1 means 2 plus 1 minus hydrogens, how many? 2. Halogens are added. 2 halogens. Is there any nitrogen atom? No. By 2 total we have to take. So finally which you got? 3 minus 4 by 2 means 2. So finally 1 is there. Coming to the map pointing, this is not for this one. So this is another one, another diagram. So we have to go through this one. How much double bond equivalence we will find. So first of all, how many pi bonds are there? 2 pi bonds are there. Okay. How many rings are there? 2 rings are there. Totally 4 is the double bond equivalence for these rings. Okay. Double DBE equal to 2 plus 2 is equal to 4. This is the value. You are getting my point. Okay. Next component is classification of carbons. Classification of carbons means I will tell you. First one, tertiary carbons, secondary carbons and primary carbons. Constitute into tertiary, secondary, primary. Another one is alpha, beta, gamma carbons. We will be there. That will be explained in next one. I mean next after this. So first of all, the tertiary. So if one carbon is attached to another carbon, only one carbon if it is, so this is called primary carbons. Now tell me, this carbon is attached to how many carbons? This carbon only, no? That's why this is called primary carbon. This is called primary carbon. Here, this carbon is attached to this and this. So this is called secondary carbon. So this carbon is attached to how many carbon? Only one carbon. So this is also primary carbon. This one, this attached to one carbon only. So primary carbon. This is also attached to primary carbon. Oh my God, this is secondary. How many carbons it is attached to? 3 carbons. This is also tertiary. So coming to this one, this is primary. This is quaternary carbocation. Understand? So finally, primary carbocations, primary carbons number. How many are there? Primary 1, 2, 3, 4, 5. 5 are there. Secondary carbon. How many are there? Secondary carbons is there? 2 are there. Huh? Only one is there. Only one is there. Only one is there. Tertiary carbons 1. Quaternary carbons 1. This much is answer. So coming to this is carbon. So now tell me how many tertiary hydrogen. Tertiary hydrogens. Hydrogens which are attached to tertiary carbon, those hydrogens are called tertiary hydrogen. That's it. So tell me primary hydrogens. Primary hydrogen. Where is primary? This one. This one, this one, this one. Total how many hydrogens are there? 3 plus 3, 6. 6 plus 3, 9. 9 plus 3, 12. 12 plus 3, 15. Secondary hydrogens. How many secondary hydrogens are there? 2 plus 1. Sorry, 2 is there. So only 2 hydrogens are there. For tertiary hydrogen, 1 hydrogen is there. For quaternary hydrogens, how many hydrogens are there? 0. So in this way we can calculate carbon is primary or secondary or primary, tertiary or quaternary, whatever it may be. Like this we have to know the nature of the carbon. So next one is alpha, beta, gamma will be there. We will write it. We will see here. So this is what is called, this is butanol, butyl alcohol it is. So this is functional group, you know, this is functional group. So functional group attached carbon is alpha carbon. Alpha carbon, this is beta carbon, this is gamma carbon, this is delta carbon, whatever it will be. We have to start from alpha, functional group attached carbon. Functional group attached carbon is alpha, next one is beta, next one is gamma, next one is delta. So these are the types of carbons, whatever it may be. So please, okay, please remember it, and if you want to screenshot it, screenshot, and it is very important for NEET exam or IIT or mains, whatever it may be. So this is the main concept. So tomorrow we will it means in next video we will discuss about what IUPAC name, how they are named, how they are numbered, okay, how they have to number. All those we have to discuss in next video. Okay, thank you for watching this video. Thank you. Okay, bye.